Hello everyone, welcome to class of fluid mechanics. Here now we are going to solve the problem based on the momentum principle and flow analysis. Your numerical problem is force exerted by the flowing fluid on the pipe end. So first of all we'll write the what is given in the question. A 45-degree reducing bend is connected in a pipeline. The diameter at inlet and outlet of pipe being 600 mm and 300 mm respectively. So here inlet diameter, this is D1, it is 600 mm, which is 0.6 meter, and outlet diameter. So this is outlet dia. This is D2, 300 mm. It is 0.3 meter, and we have given here the pressure at the inlet to bend is 8.829 Newton per cm square. So inlet pressure, it is P1, which is 8.829 into 10 to the power 4 Newton per meter square. They are given in Newton per cm square, so we converted it into Newton per meter square. So another given parameter, discharge given, or flow rate. Flow rate is Q. It is 600 liter per second. We can convert it into meter cube per second, which is 0.6 meter cube per second. Now we have to define this parameter in the figure, and we have to draw the figure here. Here the fluid flow with the velocity V1 and area at section 1 is A1. This is section 1, and here we have section 2, and pressure intensity at section 1 P1. Product of P1 and A1 is the pressure force at section 1. Similarly, pressure force at section 2 is P2A2, acting in this direction. Here in the arrow is showing, and V2 is velocity, and we can resolve here velocity because this angle is the 45-degree. Here now we get here V2 cos 45 as horizontal component of velocity, and vertical component is V2 sin 45. Here we have to resolve this pressure force P2A2. This pressure force P2A2 is acting in this direction, so we can resolve in this horizontal direction. This is 45-degree. So here if this is P2A2 and P2A2 cos 45, and we have here at vertical direction P2A2 sin 45. And now we have to find here area, and pressure at section 2 is also not given. So with the given diameter and discharge, we can find the area and velocity. Area at section 1 A1 equal to pi by 4 into d1 square. d1 is 0.6, so it is 0.2827 meter square. Similarly, area at section 2 is A2, which is equal to pi by 4 into 0.3 square, and this value is 0.07068 meter square. Now with this area and flow rate, we can find here velocity. Velocity is discharge upon area. Here velocity for V1 we can write here Q 0.6 and area A1 0.2827. This is velocity 2.122 meter per second, and V2 equal to Q upon A2, which is 0.6 divided by 0.07068. This is 8.488 meter per second. Here we have found area in velocity. Now we have to find the pressure at section 2, which is not given. We have to use Bernoulli's equation here. Using Bernoulli's equation, we can write P1 upon rho g, which is pressure head at section 1, and V1 square upon 2g is velocity head at section 1, and Z1 is the datum head or elevation head. Similarly, at section 2, P2 upon rho g plus V2 square upon 2g plus Z2. Here Z1 and Z2 elevation at section 1 and 2 is not given, so we can assume here horizontal pipe. Assuming pipe as horizontal, we can write here Z1 equal to Z2. So here we have remaining P1 upon rho g, this is P, plus V1 square upon 2g equal to P2 upon rho g plus V2 square upon 2g. We have all the parameter except P2 upon rho g. Here P2 upon rho g we have to find, and this is P1 upon rho g plus V2 square upon 2g minus V2 square upon 2g. So here P1 is we have given in the question, so we can write 8.829 into 10 to the power 4. 8.829 into 10 to the power 4 divided by, and this is rho 1000 is the density of water, and G is 9.81 acceleration due to gravity, plus V1 square velocity at section 1, which is 2.122. Here we have already calculated, so here 2.122 square upon 2 into 9.81 minus here V2 square upon 2g. V2 is 8.488 square upon 2 into 9.81. So we can calculate using calculator. P2 upon rho g comes to be 5.5575. This unit is meter. In terms of water, we can find here pressure intensity. P2 equal to 5.5575 into 9810. By multiplying this, we obtain here 5.45 and 10 to the power 4 Newton per meter square. So here we have to check this value of P2 with the pressure at section 1. Here we have here P1 8.829. P1 is greater than P2. So pressure flow from high pressure region to low pressure region at section 2, which is correct. Question is also correct and our solution is also correct here. Now we have to find the force exerted by the flowing fluid to the pipe bend. So we have to use momentum equation. We have momentum equation, sum of force acting in the any direction, which must be equal to rate of change of momentum in that direction. Okay, and I'll write here language. Sum of force acting on fluid equal to rate of change of momentum. For x direction, we can write summation of force in x direction. This is summation, which must be equal to rate of change of momentum, which is mass per second into change in velocity, final velocity minus initial velocity. Here in suffix x denotes in direction of x. So here which is equal to m dot is rho q v2x minus v1x. So here we have to find here total forces that are acting on the fluid from the figure here. Here pressure force P1 into A1 is acting in horizontal direction and P2 A2 cos 45 here acting in the negative horizontal direction, and we have here force acting on the this pipe bend. So we can make here pipe bend is experiencing a force of f of x due to water and f of y due to water in x and y direction. So fluid is experiencing a force of minus f of x in x direction and minus of f of y in y direction. So we can use this in the formula which is written here, and here force experiencing by the liquid is minus f of x and plus P1 into A1 is pressure force at inlet and minus P2 A2 cos 45. This is the force acting, and we have here remaining rho q v2x is here. We resolved earlier. Here v2x is v2 cos 45, v2y is v2 sin 45, and here at inlet we have only horizontal. So here is x component only, no y component. So here we can write here at v2x we can write v2 cos 45 minus v1x is v1. Now we have to put the value here and minus f of x. Let I will take this on the right side, which is equal to rho q v2 cos 45 minus v1 minus p1 a1 minus this is plus p2 a2 cos 45. Now we can substitute here the values. Rho is the 1000 and q is 0.6 and v2 is the velocity which is 8.488 cos 45 minus v1. v1 we found here 2.122 earlier and minus p1 is pressure 8.829 into 10 to the power 4, and we have here area at section 1 0.2827 and plus P2 is the pressure which is 5.45 into 10 to the power 4 and into A2 is the area cross section at section 2 0.07068 and cos 45 here. Using calculator we can find here minus f of x equal to minus of 19908.812. This negative becomes positive. So f of x is 19908.812 and we have to write the unit here. This is Newton. Similarly, we can find the force in y direction. Here f of y, summation f of y equal to rho q v2y minus v1y. Force in y direction. Here we have force experienced by the fluid is minus Fy and pressure force is acting in downward direction. This is negative. So P2A2 sin 45. Here minus F of y minus P2A2 sin 45, which must be equal to this rho q v2y is the velocity in y direction. Here this is v2 sin 45 degree and minus 0 because there is no velocity component in vertical direction at section 1. So here minus f of y equal to, the value is here 6324.97 Newton. Here we can write f of y equal to minus 6324.97 Newton. Okay, this is our value of forces that the pipe bend is experienced, and now we have to draw the force diagram here. Here in x direction it is f of x, which is positive 19908.812 Newton, and at y direction, which is negative, that's why we can draw in downward direction, which is f of y equal to 6324.97 Newton. So that now we can find resultant here. Here resultant is f of r. Here this resultant make angle theta with the horizontal, so that we can find here angle theta. Here theta is tan theta equal to this perpendicular, and to this base, this perpendicular is f of y and this base is f of x. So tan theta equal to f of y upon f of x. Therefore theta equal to tan inverse of f of y upon f of x. We have f of y 6324.97 divided by f of x is 19908.812, and this is 17.62. We can write in degree minute second. So if we write in this degree, 17 degree 37 minute and something second, we can write up to this only. Resultant force must be calculated. So it is f of r equal to f of x square plus f of y square. So here root under f of x, here we can write here f of x we calculated here upward side, which is 19908.812. This square plus f of y minus 6324.97 square. Okay, and this value is, resultant value is almost 20880 Newton. Okay, this is our final answer we have to find. This problem answer, check more videos in this channel.